Mrs. Arndt here. This is your week 2, lesson 3 for Math 3. We are looking at converting from rectangular to polar coordinates today. So just a quick reminder that yesterday in our notes, we filled out all of the values around the unit circle. So this included degree measures with the radian angle measures, but it also included the special right triangle values that put x and y coordinates on those points that are all 1 unit away from the origin. So keep that handy, we're going to need it. That's just a look at the special right triangles from yesterday. We won't need that. Okay, so here we are. We're taking a look at converting from rectangular to polar coordinates, because on the rectangular plane, of course, we have our x-axis, we have our y-axis, and we can basically turn this into a polar plane by creating circles. That's a 1 radius circle. Here at 2 units, that's a radius of 2 units on the circle, 3 units. Okay, so my circles are looking a little fishy because it's a sketch. Okay, so we have ourselves a polar plane now with different radii and of course our angles going around. So one thing is that the radius that we're using may not necessarily be 1. So we may not be able to use the x and y values exactly from our unit circle, but those angles will come in handy. So let's take a look at one coordinate pair, the point 3, 4, and see if we can turn that rectangular x and y into polar coordinates. So for starters, I know it's got to be an x and a y. It can't be r and theta because this right here is not an angle measure. So it's definitely x and y. So the point 3, 4 is somewhere up here, and if we want to know how far out that is from the origin or from the pole, we need to know that straight line distance. So basically using a right triangle with legs of 3 and 4 units, we could find that straight line distance. This is the Pythagorean equation. X squared plus y squared equals r squared. We've used this before, so it shouldn't be terribly new. So 3 squared plus 4 squared equals r squared. We add up 9 plus 16, and we get 25 equal to r squared. Last step is to apply that square root, so I know the r value is 5. R is 5. So to solve for r, we need the square root of x squared plus y squared. That's the equation, that's the formula for r. Next up, to find theta, well, we have an exact y and we have an exact x. We also happen to have r at this point, but mathematicians are going to use tangent. Tangent of our rotational angle is equal to y over x, because for our angle, tangent is opposite over adjacent, so that's our y value over our x value. So that's a key piece right there. So tangent of theta, we're going to put our y value 4 over our x value 3, and then for us to find what theta is exactly, we need inverse tangent of 4/3. Inverse tangent of 4/3. So grab your calculator or your Delta Math calculator, make sure you are in degree mode, and we'll take inverse tangent of 4/3. And that's about 53.1 degrees. So to find theta, we use inverse tangent of y over x. And when we go about writing the polar pairing, we definitely want to use parentheses, write our r value, use the comma, and write our theta, our angle. And that's our final answer. So those are the 2 formulas that we're using. When you hit the Delta Math practice problems, there are some maybe different looks to it, different things that they will expect. So I've got them split up into 2 categories, the easy but weird ones and the slightly harder but more normal problems. So we'll take a look here at the easy but weird. So here in example 1, we're located at 0, 3 times the square root of 2. If I were to plot that, it would be straight up because we wouldn't go left or right at all, but we would go up to a height of 3 square root of 2. So without doing any work, I know the radius has to be 3 times the square root of 2. That's its straight line distance away from the origin or the pole. So that's the radius. The angle, well, it's straight up. That's 90 degrees. Now, delta math is going to require you to put down the radian angle. So having this handy, we see, yep, 90 degrees is exactly pi over 2. So 3 square root of 2, comma, pi over 2 is the polar form for that rectangular point. Another easy but weird one, we've got the point -6, 0. So if we plot this, we go to the left 6 units, and then we don't go up or down at all. That's where we're located. So for the radius, the distance from the origin of the pole straight over to where we are, that radius is 6 units. So the radius is always positive. It's 6 units. That's the distance. Meanwhile, the angle, well, that's our 180-degree location. And if we take a look, remind ourselves, oh yeah, that's pi for the angle. So our polar form of that location is 6, pi. So like I said, those are the easy ones, but they might trip you up. Anytime you see a 0 somewhere, you know that we're on an axis, and it's going to be one of the easy but weird ones. So let's take a look at examples 3 and 4. The harder ones, but what I consider more normal. They're not going to be on an axis. So here we have x and y, -3 square root of 3. So if I were to plot this, -3 up square root of 3, we're up here somewhere in quadrant 2. So we will have to use these formulas. So the radius equals the square root of -3 squared plus the square root of 3 squared. So be very, very careful with these situations that require parentheses. We need the square root first, then we need parentheses around -3. The square goes on the outside of it. Plus, now we've got a similar issue here, square root of 3, close that up, square on the outside of that square root of 3, but it's still underneath the big square root. And we get this crazy decimal number. Well, delta math doesn't want that. Delta math wants the interior simplified. So -3 squared, that's a +9. Square root of 3 squared is just 3. So what we're looking at under the square root is a 12. So this radius is the square root of 12. So we're just going to leave it just like that. We don't have to simplify it into simplest radical form at all. The next part would be coming up with our rotational angle. So let's use inverse tangent of square root of 3 over -3. And let's see what our calculator tells us. Inverse tangent, square root of 3 divided by 3. Make sure that your square root of 3 is ending, that you have the division after that, and then the 3, all inside that inverse tangent. And it spits out 30 degrees. Well, 30 degrees, oh, it can't be 30 degrees. I missed something. I missed that negative that should be in the bottom there. So let me go through and fix that. There we go. Don't miss that part, because the calculator tells me -30 degrees. And -30 degrees is exactly halfway from where we should be. Halfway around the circle from where we should be. So I'm going to take that -30 plus 180. So that's the thing to watch out for on this formula. We have to check the quadrant that we're in, because if it's wrong, we need to add 180 degrees to get onto the other side of our circle. So -30 plus 180 is 150 degrees. And hey, that's correct. That's in the correct quadrant. So now all we need to do is go here, make sure we write down what 150 degrees is in radians. So this final answer is square root of 12, 5 pi over 6 for the radian angle. And that is our polar coordinate pair. So feel free to stop there, head on over to Delta Math, practice those up, and have a wonderful day.